This is Physics 2, Lab 3, the magnetic field of a bar magnet. Introduction. So the goal is to visualize the magnetic field and model it in glow script. The results is the magnetometer moves closer to the magnet. The measured exponent of the magnetic field increases. And the magnetic dipole moment is, we will find, is 1.49 amp-meter squared. And the measured off-axis magnetic field is 7.8 to negative 5t. And the simulated off-axis magnetic field is 2.95 to the negative 5. So for the first of the formulas, we have the superposition formula. Then we have the electric field of the loop, electric field of the dipole, electric field of the dipole perpendicular, the electric field of how to calculate using an observed location, and then we have mu equals I current times the area of the loop, and gives you I times pi r squared because we're using a circle of loop. Experiment info, we have the magnetometer, the surroundings of the bar magnet that we treat as a dipole, and we test both the on and off axis magnetic fields. For the data results, we find that as distance decreases, the B field increases, and if we take the natural log of B over the natural log of R, which is the distance, we find that there is a linear negative correlation between the two. Now here's the current slide of the code. Yeah, just basically sets up the magnet direction, the values for the magnetic stuff, and then it sets up the dipole below, and the formula to calculate that, which is just the formula we used earlier in the video and just in code form. And for this code, we have the observation of the axes and the perpendicular directions, and basically this is the code used to find out basically the magnetic field of each point from the observed point and basically the direction of each of them, which gives us this. And the results, magnetometer, the distance between the magnetometer and magnet decrease, the magnetic field increases. Now the magnetic dipole moment is 1.49 amp meters squared, and the measured off-axis magnetic field is 7.8 e to the negative 5t, and the simulated off-axis magnetic field is 2.95 e to the negative 5t. Now the sources of error, I calculated this maybe near other electronic devices, maybe walls and sockets that carry current, and then just measurement errors with the device and distance, and then me. And then what if you did not compensate for the magnetic north, but laid a stick at some angle without respect to the Earth's magnetic field? The x and y components would be different because magnetic north would then affect both the x and y components. And what if you were to stick two identical magnets together end to end and run the experiment again? The magnitude of the magnetic field would be greater than the original, about double. Distance would decrease due to increased magnetic field.